Alright, so let's talk about open sound control, or OSC, open sound control. Now, of course, before we talk about open sound control, we have to talk about MIDI. So MIDI, as you may know, stands for Musical Instrument Digital Interface, originally created to record and play back and manipulate musical data so that computers can, we can interact with computers and music in a more natural way. In its simplest form, MIDI had a few sort of data types that it uses to try and work with music. The most fundamental would be the note. So in MIDI you can have a MIDI note, and the note actually has two values associated. That is the note value itself, and this will be in the range of 0 to 127. So for example, if we were to play note 72, that relates to the note on a piano C4. The other component of a note is velocity. Velocity, again, is just a value between 0 and 127. And velocity is how hard that note is hit, or how loud it should be. Some, element of how much gusto is put into the note. The other data type that you might come across and use quite often in MIDI is the control change message, otherwise known as CC, standing for control change. And again, the control change message has two values associated with it. One is sort of the control change ID. Which parameter are you trying to control? Control change is there to work with parameters that aren't necessarily discrete notes, so something like volume, or the cutoff of a filter, or the resonance of the filter, or just the general brightness of a sound, something that's a little bit more almost analog. So control change will have an ID. Let's say we're trying to control the parameter number 12. And it'll also have a value. This is again a value between 0 and 127. Now, MIDI went on to be used for a lot of other things other than just music. Notably, sort of just as a way of interfacing with a computer in a natural way, you'll often find MIDI controllers with faders and sliders used to work with audio, video, lights, all sorts of things. Even though that wasn't necessarily what it was originally created for. And one of the sort of quirks is with MIDI is, one, you're sort of restricted by the protocol itself, in that you can send notes and receive notes, you can send control change and receive control change. There are a few other things you can do, but it's quite limited. And another limitation is here. So if you want to control, say, the brightness of a light, and you're controlling that brightness with a knob, that knob has 128 discrete values that it can be at any one time. So I can sort of demonstrate this problem here. Let's go. I've got this little patch set up, this smiley guy. So I've got a dial here. I've got two dials. Both of them are controlling the hue of this panel. The difference being, this dial here is sending out integers between 0 and 127. And you'll notice, if I turn this slowly, you can see that the panel steps through colors. You can see those discrete steps. And so this is sort of a problem we have with the resolution of the amount of control that we have. What would be really nice if we could use a floating point value like this. So this dial is sending out a floating point value. which in this case has 1, 2, 3, 4, 5, 6 or 7 points of precision. I'll give him a wonky eye. Maybe more, I don't know what's going on under the hood, but you can see there's much finer control, and as a result, the change in color is much smoother. So wouldn't it be great if we could do that when we want to control our video or our lights or our audio? And thankfully we can, thanks to OSC. So OSC, Open Sound Control. I'm not sure how old OSC is. It's fairly new on the block, maybe 10 years, I might be wrong, maybe it's been around for longer. But funnily enough, Open Sound Control tends to be used in video software and sort of general interactivity a lot more than it's used in sound software, things like Ableton or I don't know, anything like that. You know, your regular DAWs, Cubase. These tend not to have open sound control, but video software like Resolume, VDMX, sort of media programming software like Max, Pure Data, Chords Composer, all of these rely very heavily on open sound control. And again, in its simplest sense, OSC messages have a few components. Well, two components. They have an address and they have a value. The address is structured like the way we structure directories for web addresses or directories on your computer. If I bring up a Finder window, hopefully this doesn't, took me somewhere weird, doesn't matter. If we have a look at my hard drive here, let's go in here, have a pop around. You'll notice down here, well, you'll be familiar with this anyway. I can go to /users, maybe I can, /me, /this. So this sort of address structure you're probably familiar with. And that's what Open Sound Control uses. So you can define a parameter and give it an address. I might say want to control some sort of video, and it might be layer number 1, and I might want to control the opacity. So this here would be the address of my OSC message. Similarly, I might want to be controlling, say, the audio. I might want to control channel, can't spell, channel 6, or maybe even channel /6. And I might want to control effects, distortion. Right, so this would be my address. Both of these are perfectly valid addresses. And similarly, you can see how this can make things nice and readable, because if I want to control video layer 1 opacity, then I could might be able to control video layer 2 opacity. These are all our OSC message addresses. The other component of an OSC message is the value. Values can be floating point numbers like this. I'm not quite sure what level of precision they get up to, but it's a lot more than what you get with a MIDI CC message. They can be integers or whole numbers like this. They can be strings. Hello. All sorts of stuff. The point is, Open Sound Control is very, very flexible. I'll provide a link to the Open Sound Control spec, where you can have a look at some of the intricacies involved in Open Sound Control. There are things like timestamps and ways to chunk up the data to be able to do things like even send audio, or you can even send probably video. I don't know, maybe. You can do all sorts of stuff. But in its most basic sense, and the sort of sense that we'll be using it for in most situations, you'll just have an address and a value. And most often it'll be an address and a value between 0 and 1, a floating point value between 0.0 and 1.0. These are often called normalized values. Just make it easy to know, hey, that's 0.5, you know that's the middle of your value, 1.0 is full, 0.0 is all the way down. Cool. So that's OSC. That's how we're going to be working with it. So let's have a look at how we might work with it in Max. Actually, let's take a step back. So now we've got our open sound control message. We know say we want to send this. I want to be able to send this message. Where am I going to send it? How am I going to find the computer that I want to send to? I forgot to mention that open sound control is sort of made for our the current state of computing, which is heavily networked. It's very much designed to work over a network. So if I want to control some networked device from somewhere else somehow, and they're connected over a network, then OSC is the thing to use. And because of that, we work with sort of standard network protocols and things. So an open sound control device will have there are two things I need to know to send to a computer, or to send to a device to control it with OSC. The first thing is its IP. Whoops, wrong thing. Or its IP address. And the other thing is a port. So its IP address will be defined or be a property of the network that the computer is connected to. On Mac, you can find it by holding Option and clicking your Wi-Fi indicator. I'll have to censor out some of this information, but you can see here is my IP address. In this case, it's 192.168.0.100. I'm on the network Splunk. If you're on a Windows machine, you can find out your IP address by going into the command prompt and typing IP config, and that'll give you, and hitting enter, and that will give you what you're looking for is the IPv4. That'll be your IP address. So in my case, whoops, my IP address is 192.168.0.100. Now the port is just a number that I'm going to specify to say, hey, this number is what I'm going to look for any addresses that say, hey, I want to talk to this number. So I'm going to make a port called 505050. 5050. And now if I want to talk to this computer, I can say, hey, I want to send an OSC message to this computer at this IP address, and this computer will be listening on this port 5050. Something to keep in mind is that once an application is listening to a port, no other applications are going to be able to listen to that port. So you essentially lock off that port when you listen to it, which is by design. There are certain ways around that, which we can get to later. All right, so let's get an open sound control message into this computer. I might just bring up a camera so I can show you something. Okay, so I've got my phone here. My phone is connected to the same network, Splunk, and it is running an application called touchOSC. touchOSC is an application that lets you build touch interfaces that send and receive OSC messages. There are lots of applications that do a similar thing. touchOSC is sort of I'd probably say the industry standard. There are fancier ones and less fancy ones, and free ones and more expensive ones. But touchOSC is, the benchmark. So in touchOSC, see if I can see this. You can see I've got some settings. I've got host. Host is the computer that I want to talk to. What computer do I want to talk to? And you can see, if I can get this here, I'm sending to the address 192.168.0.100, which is the IP address of this computer. And the port that I want to send to is the outgoing port. I'm sending to port 5050. Incoming port, you don't really need to worry about. That is if I wanted to send an OSC message to this device, I could send it to that port. And you can see there, just to be sort of useful, it's telling me the IP address of this phone. So I can, if I wanted to send an OSC message to this phone, that's the IP address that I need to use. Okay, so that's what I've got set up there. Now let's do the OSC side of Max MSP. So to send or receive an OSC message, we need to use the UDP objects. Why UDP? I thought this was OSC. What's this UDP thing? Well, UDP, just to take it a step back, you might have heard of TCP or TCP-IP, which is what we use as the internet protocol. UDP is similar to that. And you can think of UDP and TCP-IP as the envelope. So that's the envelope we might want to use. What we put inside that envelope is the OSC message. A little bit of trivia. You can think of the difference between UDP and TCP/IP is that TCP/IP has a return address. If you think of it as a letter. So if you send something over TCP/IP and it doesn't make it to the other side, you hear about it. It tells you something went wrong, so your computer can go try and send it again. UDP has no return address. So you send off your OSC message, it may or may not make it to the other side, but you're not going to know either way. So UDP is generally used if it doesn't really matter if it doesn't get to the other side. You just want to be able to send it off as quickly and as efficiently as possible. So the object that we're going to use to receive an OSC message is UDP receive. And this is going to require one argument. You can see here it requires an argument port, which is an integer. And in this case, the port that I want to listen to is port 5050. I'm going to connect that to a print object. And now, I'll bring up the Max console. Now if I wiggle one of these knobs, you can see in my Max window, there are all my OSC values coming in. Oops, it's hard to do this through a camera. Right, so that's working. So now we're able to send messages from a phone to Max. We want to do something with them. And what is handy is so now we want to do something with them. What we can do is filter the messages that are coming in by their address. Because what we want is, this is the value that we want. We want to be able to look through all of the messages that are coming in and find the value at a specific address. The easiest way to do that is using the root object. So I'm going to create a new object, hit N, start typing root or route, and there it is. Now the route argument can take any argument that you want to give it, and a series of arguments. And what those arguments are, in this case, is the address of the OSC message that we're looking for. What it will do is look at everything coming in. It'll see if something matches what you're looking for, and if it does, it'll spit that out of the associated outlet. So for example, let's look for /1/fader1, and maybe I'll put a space and then we can look for another message as well. So let's look for /1/fader2 and /1/fader3 and /1/fader4 Hello, let's just look for those faders. You can see it's given us a series of inputs, and if we outputs, and if we hover over those outputs, we can see it's saying outputs if input matches /1/fader1. So I'm going to connect this to the right inlet of a message box, so it'll store whatever comes in here in the message box, and I'll do that for all of these. And I'll connect it to my UDP receive. So my OSC messages are going to come in through this UDP receive object. They're going to go into this route object. If any of the addresses happens to match these arguments, it will send the message out of its corresponding outlet. Let's see if that works. So I'm going to try, I reckon this is probably fader 1, so let's try fader 1. You can see there comes the value for fader 1. Let's try fader 2. There's my value for fader 2. Fader 3, fader 4. Now this top one's fader 5. The route object has an extra outlet, you can see, and that says route, it sends out the input if the input doesn't match any of your arguments. So let's have a look at what's happening. I'll connect this up to a message box. I'll just make it a bit bigger. Alright, so I'll start by sending out those other faders. So there's 1, 2, 3, 4. Now here's fader 5. We don't have an argument for fader 5. Let's see what happens. There you go. So it's just passed that message straight through, including the address. So, you know, what that's handy for is you can end up chaining these together, right? So what if I make another route object? And we'll look for /1/fader 5. We can now plug this into our other route object, and now we can look for something else. That's just sort of an example of what you might be able to use a route object for. You can see there's fader 5 coming in. Now, of course, once we've got these values, we can hook them up to control anything we want. Let's stick a Visi effect on this video, because why not? Effect. Let's go with a sampler. That's a fun one. I'll connect my camera into that. Alright, we're going wacky. What's interesting? Horizontal gain? Gain's a good one to try. Okay, let's try and control gain. I'll turn this off for the moment. Let's control gain with fader 5. So all I need to do is look for the inlet that's controlling gain. That's bound mode. Data received in this inlet sets the gain. So let's connect our fader 5, to the gain. And I'll turn the effect on. And now I'm moving fader 5, and that's adjusting my gain. Oh, might actually be able to still see me if I do something like... There we go, here I am. So fader 5, craziness. There you go. Cool. So we've covered receiving objects, receiving OSC messages. We've covered looking for particular addresses to get those values out of those particular addresses and use them in your program. What if we want to send OSC messages? Say, for example, what if rather than controlling the computer with this slider on my phone, I want to control this slider on my phone with my computer? Well, we can do that. And just like we used a UDP receive object, we need to use a UDP send object. So I'll say I'll make a new object. I'll start typing UDP, there it is, send. You'll see this takes 2 arguments, a host and a port. Now I can look on my phone to find the IP address. In fact, I'm going to. So I can see touchOSC is telling me quite usefully that my IP address happens to be 192.168.0.104. But what if we don't know our IP address? Well, we can use what's sometimes called a broadcast, or what you can think of as a wildcard. So since my network starts 192.168.0. something, basically any computer on this local network, its IP is going to start with this address. And usefully, we can use this number, 255. So 255 in this case is a magic number. You can think of it as a wildcard. And what it will do is if we put 255 in there, this is going to send to every address from 192.168.0.1, .2, .3, .4, .5, all the way up to 254. It will send to every single computer, and if any of those, or every single device, if any of those devices are listening on the port that we set, then they'll be able to receive that message. So I'm going to try that. I'm going to say UDP send. I don't actually know what my address is. Let's say it's 192.168.0.255. But I do know I want to send to port, in this case, my phone is listening to port 9000. 1, 2, 3. And the message that I want to send is this. Let's try and control fader 5. So we want to send a message like this, /1/fader 5 my message. In order to send that message, we're going to need two things. We're going to need our address and our value, and we're going to need to stick them together. So I'm going to start with my value. I'm going to use a flow number box, or a float number box, or a flow num. So I'll start typing FLO, there it is, flow num. And you can see this is just a floating point number from 0 to 1. And if we have a look at what it's outputting, you can see it's just a bog standard floating point number. So we want to connect that to this little piece of information, /1/fader 5. We're going to do that using the prepend object. So I'll type N, P, R, E, P, there it is, prepend. Prepend will take its argument and stick it to the front of anything else that comes in. So for example, our argument is going to be, what we want to stick at the front is /1/fader 5. So we'll use that as our argument, /1/fader 5. And now if I run my float number box into that, and I have a look at what that's spitting out now. Actually, let's stack these message boxes on top of each other so we can see the difference. So this message box is receiving this, and this message box is receiving this. If we do this, you can see the number's the same. All this prepend object has done is tacked on /1/fader 5, and then the floating point value that we want to send out. So this is good. This is our OSC message ready to go. Let's plug it into our UDP send. Go back to my phone. So if we're lucky, there we go. So you can see as I send this message, I'm setting the value of the slider on my phone. Now this can be useful in a lot. You can find creative uses for this. Like why would you want to control a slider on your phone? Well, what if you want to give someone a cue, like someone's speaking and you want to be able to show them where they are in sort of a timeline so they can judge how fast to talk? I've used it in a show before where I've needed to let someone know something's gone wrong. So for example, we were using a camera and sometimes the camera would shut off. So if my live feed shut off, I wanted to be able to just send a signal to them. I couldn't yell across the road. We didn't have comms. So we used just a phone, someone's iPhone, put touchOSC on it, put a big button on it, and then I could just send an OSC message to make that button flash. And so that would give them a visual cue that something had gone wrong. So lots of uses for this sort of thing. Two things I want to cover before wrapping this up. So in this case, using this wildcard or this broadcast address, this was great, this worked well, and it's sort of a good lazy way to do it. If you're only using two objects or two devices, You don't really need to figure out their IP addresses. Like, it's just a little bit more work. You can just put in 255. There's a good chance it'll work. What if I can't even be bothered finding out what the rest of my network address looks like? Well, what would you expect to happen if I sent 255.255.255? If I sent to this address? And the answer is, I'd be trying to talk to every single computer that I could possibly reach through my network. This might not be a problem. If you've just got 2 computers and a router, this might work. Let's try it. So I'm going to send to 255.255.255.255, also known as broadcast. I'm going to, here's my phone. So this phone's IP address hasn't changed. I've actually forgotten what it was, but hopefully that doesn't matter. There you go. So we're still sending using this address, 255.255.255.255. So sometimes this is just my go-to. If I just want to get something working quickly, I don't want to stuff around with IP addresses, maybe you want to set it up so that when your computer connects to the router, no matter what IP address it gets set, it will still be talking to the other computers on the system. As long as they're listening on the appropriate port, this will be fine. You might find that some routers don't like this, some computers don't like this, and it just won't work. In that case, you've got to go and find the IP address, but it can be a good first step for just getting something up and running, you know, quick and dirty. Don't want to go and figure out the IP address, just send it to broadcast and it'll work. The other little tip, final tip, I've been using a float number box here. If I select that float number box and hit Command I, it will bring up an inspector which has lots of useful little changes. Some are just visual things, like these are good to play around with. For example, let's change the background color. I might want to change it to orange because I like orange. And now you get a nice bright orange sort of flat number box. That's quite nice. But other things are, you know, moving this number box around, you'll notice I can put in whatever number I want, really. But I want to send out normalized values, so I only want to send out between 0 and 1. You'll find in the inspector, Command I brings it up. I've got a minimum and a maximum value. So these are very useful. I can type 0.0 and 1.0. And now my number box won't let me go above 1 and won't let me go below 0. So you can sort of more carelessly push it all the way up to 1, push it all the way down to 0, and it just makes it a bit easier to work with. You'll find these are available in some of the other objects. The other ones to look at might be a dial, so that just gives you a knob. And you can see here, it's got number of steps and range. It's also got this float output, so we want to turn that on so that we're outputting a float, otherwise by default it will output integers. And I want a range of 1. And now, if we look at what that's sending out, same thing, a float from 0 to 1. Another thing to look at might be a slider, S-L-I, there it is, slider. And in its inspector, you can see it's a similar thing. So we want to set a float output, so we're sending out a floating point. We want a range of 1, and so now it goes from 0 to 1. And we can control something with a slider. I can hook that straight up to my OSC formatting object, and there you go. I'm now controlling my slider with another slider. Yeah, so things to do, set up a couple of computers, see if you can control another computer, you can see if you can get them talking to each other, play around with broadcast, you know, get every phone you can possibly get your hands on and some sort of free OSC application and see if you can control them all at once, because you can, and it's good fun. Yeah, hope that's useful.